We're going to be finding the future value and compound interest, and we're going to use Excel, and we're going to use a formula for calculators. We're going to not find the effective interest rate because that's not a competency that we have at CVTC. Nor are we going to find the interest compounded daily using a table. In some loans, interest is computed once during the life of the loan. That's what we've been doing, simple interest. Now, interest is computed more than once during the life of the loan, and that interest accumulates so that it becomes part of the principal for the next interest calculation. This is called compounding interest. The interest period is the amount of time after which interest is calculated and added to the principal. The compound interest is the total interest that is accumulated after more than one interest period. And the future value or maturity value is that compound amount. The periodic interest rate is different than the interest rate because what you need to do is divide the yearly interest by the number of compoundings. So if it's compounded monthly, you would divide by 12. If it's compounded quarterly, you'd divide by 4. So if you have 12% interest compounded semi-annually, you'd divide by 2 and get 6% interest per semi-annually. So we use the formula that says the periodic interest rate is the annual interest rate divided by the number of periods per year. And on our calculator, or I'm sorry, in the formulas, this is usually abbreviated lowercase I, or in Excel, it's called the rate. All right, so if we have a 12% annual interest rate, 12% annual interest rate with what in the world is going on here? 12% annual interest rate with 4 compounding periods, we would take 12 divided by 4, which is 3%. That's the periodic rate. 18% compounded monthly, that would be 1.5%. 8% compounded quarterly would be 2%. Now, not only do you divide the interest by the number of periods, you also multiply the number of periods by how many years it is. So in Excel, we would start typing equals FV, and FV stands for future value. And the rate is the periodic rate, the number of periods. We aren't going to use payments because that's for annuities. We would use the present value, which is also called the principal. Okay? And when you type equals FV into Excel, you will get a bunch of commas, or you can type the FX button, which is right next to where you would type, and you would see this table here. So we would fill in the periodic rate, number of periods, and the present value, and then press enter. Find the future value of a loan of $800 at 13% for 3 years. On our calculator, we would press 800 times 1 plus 0.13 to the third. Here's our third, here's our 0.13, and here's our $800. In Excel, notice here's our rate. Every comma switches things, so this is the number of periods. Notice there is no payment, but there is the $800. It comes out to be in red because this was positive, so this is negative. If we would have written negative 800, then this would have come out in black. So, in this case, $10,000 compounded semi-annually. Notice we took the 8% and divided it by 2. we took the 3 years and multiplied it by 2 because there's going to be 6 semi-annuals in 3 years. In Excel, we did the 8% divided by 2, the 3 years times 2, and the $10,000, and we got $12,653.19. Philippe Rivera's savings account has a balance of $39.39. After 3 years, what will the amount be at 1.7% compounded quarterly? Okay, you notice we took the 39.39 times 1 plus the 0.17% compounded quarterly, so we divide it by 4, for 3 years times 4 quarters. Whatever you divide by, you have to multiply by later on. And since they didn't want the future value, they wanted the amount of interest, we subtracted the 39.39 from it, and we got $205.65. Now notice Excel and the computer disagree slightly, and that 1 penny will be allowable difference. Simple interest is interest earned on interest. Nope, that's compound interest. When interest is added to the principal and interest is again calculated on a new process, on a new balance, the process is known as compounding interest. When interest on an investment is calculated more than once a year, this is known as compound interest. The length of time between which the interest on a loan is compounded is known as the future value. Nope, that's known as the interest period. Total amount at the end of the compound interest period is called the future value. That's true. The original amount of the loan minus the compound total is the interest. The terms of the loan indicate how often interest is compounded, and the future value minus the principal is equal to the compound interest. That's true. Okay, it could be tedious and time-consuming, and that's why we use the formula future value is present value times 1 plus the rate, periodic rate, and then to the n, which is the number of periods. So, find the compound interest, $500, compounded annually, so that's why it's 0.08 for 6 years to the 6th, and we get $797.44. But we're supposed to find the compound interest, so we need to subtract the $500, and we get $293.44. So then if we were using a calculator, we would subtract the $500. Find the future value, $2,000. Notice the $2,000 invested for 4 years. There's the 4. There's the 4. Compounded semi-annually, so that's why it's times 2. And that's why it's 8% divided by 2. Notice we did the same thing again. And then when you subtract the $2,000, that's the interest, $737.14. And then the compound amount is $2,737.14. Notice you have to use the fraction key on your calculator when you get to this spot right here, and your to the key right here for that other part. Okay. So, 3 years, $5,000 investment, 6% compounded monthly, right? So we divide by 12 and we multiply by 12. Subtract the 5,000, you get $3,983.40 worth of. Oh, I'm sorry, I messed that up. This should be $983.40 when you figure the interest. I better check to make sure that we did that other one right. 2,000, I'm pretty sure we did. Yep, we did. Okay. And so we don't do the APY or effective rate at CBTC. The amount of money needed in the present to yield a desired future amount is called the compound total. Nope, it's called the present value. Present value can be found by dividing the future value by 1 plus the interest rate converted to a decimal. and then to that certain power. So I'm going to say false on that. Present value takes an amount in the future and calculates the value needed to invest today to yield that amount. A present value calculation cannot be verified using compound interest table. I have no idea because we don't use the compound interest table.